Hi, welcome to my channel pibyme Maths. This is WST02. Here we are solving January-February 2023 Statistics 2 paper. Let's look at question number 1. A shop sells shoes at a mean rate of 4 pairs of shoes per hour on a weekday. Okay, part A. Suggest a suitable distribution. Definitely when something is happening at a constant mean rate, that's Poisson distribution, right? Suitable distribution for modeling the number of sales of pairs of shoes per hour on a weekday. You can just write P of 4. Part B. State one assumption necessary for this distribution to be a suitable model. So whenever they say one assumption, we can write they are selling shoes actually. So you can write shoes are sold independently and at a constant rate. Though it's a one mark question, we write these 2 points actually. That's all. Let's move on to the next part. Find the probability that on a weekday the shop sells more than 4. Okay, we know X follows Poisson distribution of 4, right? 4 per hour on a weekday. So they say more than 4. So X is more than 4, which is same as 1 minus X is less than or equal to 4. So the lambda is also 4. The value of X is also 4. Okay. The lambda is 4, that's the 8th column, X is 4, 6288, that's 1 minus 0.6288, so we'll get 0.3712, that's the answer. Double I know. More than 4 pairs of shoes. Find the probability that on a weekday, the shop sells more than 4 pairs of shoes in each 3 consecutive 1 hour period. 1 hour period selling more than 4 shoes. This is the probability. They say 3 consecutive periods. So take the probability. X is more than 4 times X is more than 4 times X is more than 4. Which is same as 0.3712 power 3. Let's calculate this. 0.3712 to the power 3. 0.051147, 0.051147 ... Or you can round it to 3 significant figure. That's all. Part D now. The area manager visits the shop on a weekday. The day after, an advert for the shop appears in a local paper. Okay. So in a 1 hour period during the manager's visit, the shop sells 7 pairs of shoes. Usually in 1 hour, the mean rate is 4, right? Now they sold more than 4 actually, 7. Okay, take it as 7 as the observed value. This leads managers to believe that the advert has increased the shop's sales. Stating hypothesis clearly, the hypothesis is it was 4. But now the manager believed it is increased actually. And the observed value is 7. It's an upper tail test. So you need to find X is greater than or equal to 7. Which is same as 1 minus X is less than 7 or less than or equal to 6. So I'm going to find the value of lambda is equal to 4. X is 6. Lambda is 4. X is 6. So it's going to be 8893. 1 minus 0.8893, it's a 0.1107 is bigger than the significant level. If it's bigger, do not reject H0. So we do not reject it, we reject this. So the manager's belief is there is no sufficient evidence to support manager's belief. So we need to write there is insufficient evidence. There is insufficient evidence to support the manager's belief. Or you can continue writing it that the advert has increased the shop sales. But you need to write this conclusion, otherwise you will lose a mark. Question number 2. A bag contains a large number of coins. It only contains 20 peso and 50p coins. A random sample of 3 coins is taken from the bag. List all the possible combination of 3 coins that might be taken. Okay, we are going to start from 20 and write all the combinations. We need 3 coins, so it can be 20, 20, 20, or 20, 50, or 50, 20, or 50, 50. We got all combinations starting from 20, right? And then we write the same combinations starting from 50. So I'm going to copy this whole thing, paste it here. So I'm going to write the same combination starting with 50. So we got total of 8 combinations, possible combinations, that's all. So you write all these 8 combinations, you will be given 2 marks. Part B. X bar represents the mean value of the 3 coins taken. Part of the sampling distribution is given. Find the value of A and B. What are the mean values for these combinations? Mean values means you need to add the numbers, divide by 3, right? So this is going to be 20, this is 15. So they put 20 and 50 in the table, right? So what are the other 2 values? Take one other combination. Okay, for example, this 20 plus 20 plus 50, that's 1790 divided by 3. So you're going to get 30. That's one value. We take this 120 divided by 3, you'll get 40. So you can simply write A is equal to 30 and B is equal to 40. You don't need to show any working. Next question. The probability of taking a 20p coin at random is P, 50p coin at random is Q. Find the value of P and Q. Okay, I'm going to put all the combinations here to explain this. Okay, here for the first one, the mean is 20, right? The mean is 20. So look at this sampling distribution here. When the mean is 20, the corresponding probability is this, right? So when mean is 20, the corresponding probability is 4913 over 8000. But how did we find this probability? We need to multiply the probability of this, right? So which is P times P times P. So P cube is equal to 4913 over 8000. P is cube root of this. 4913 over 8000. 17 over 20. You can use the same method to find Q. Now in the table, 50 is 27 over 8000. So P of X bar is equal to 50 is 27 over 8000. That's basically 50 comes from this combination, right? So take the properties and multiply. Probability for taking a 50-cent coin, 50p coin is Q. So Q times Q times Q. Q cube is 27 over 8000. You can find Q. Cube root of 27 is 3 over 20. That's all. That's just another 2 mark question. Find the value of C and D now. I'm going to put all the combinations here. So what is C? Look at the table. C is the probability corresponding to 30. D is the probability corresponding to 40, right? So we need to find P of X bar is equal to 30 using these combinations. So P of X bar is equal to 30 is, you get 30 from this one. The mean is 30. This mean is 30. and this mean is also 30, only 3, right? So the probability is 3 times similar combination, 220, 150. We know the probability of taking a 20p coin is P, 50p coin is Q. So it's going to be P squared times Q. So we know the value of P and Q, sub in here. P is 17 over 20 and 3 over 20. 17 over 20 square, you get this value. That's the value of C. And then P of x bar is equal to 40. You are getting these combinations, 120 over 2, 120 over 2, 120 over 2. That's basically 3 times 120p coin. So 1p times 250s. So 3 over 20 whole square. That's the value of D. 3 times 17 square times 3 over 20, not 20 square, 20 square times 20, 20 cubed. 2601 over 8000, that's the value of C. This value is C. And then value of D is 3 times 17 times 3 square divided by 20 cube again. 459 over 8000. 459 over 8000. That's all. 3-mark question. Let's move on to the next part now. Part C now. Let M represents the mode of the 3 coins taken. I'm going to put all the combinations here and let's find the mode of each combination. Mode is the most repeated one. Here is 20, 20, 20, 20. And then 50. There is 50 here, 50 here, 50 here, 50 here. So mode M takes 2 values, 20, 50. So when M is 20, there are 4 similar combinations. 4 times P square times Q, which is 4 times P is 17 over 20 whole square times Q. And then when mode is 50, there are 4 similar combinations. Oh, sorry, I made a mistake here. There are 3 similar combinations and this one is slightly different, so I need to put 3 here, 3 times, and then this one is just P cube plus P cube, which is 17 over 20 whole cube. Now we are done with this. For 50 now, there are 3 similar combinations, not 4, 3. So 3 times P times Q square, there are 250s, plus Q cube. So 3 times 17 over 20 times 3 over 20 whole square plus 3 over 20 whole cube. So let's calculate these values first. 3 times 17 square times 3 divided by 20 cube plus 17 over 20 whole cube. 17 over 20 whole cube. 3757. The value of this is 3757 over 4000. We can just write it in a table because they want the distribution. So just draw a table. Small m, P of capital M is equal to small m. M takes 2 values, 20 and 50. For 20, the probability is 3757 over 4000. For 50, you can put it as 1 minus, but it's still better to verify this whether this step is correct. So it's 3 times 17 times 3 square over 20 cube plus 3/20 whole cube. 243/4000. 243/4000. So definitely when you add both the probability, you will get 4000/4000. That's 1. That means it's correct. Question 3 now. Superbones is a manufacturer of tennis balls. It knows from the past records that 10% of its tennis balls failed a bounce test. Okay, it can be a probability of success. Find the probability that a random sample of 10 of these tennis balls. Okay, you see, you can't immediately take it as P actually. You need to read the question carefully, completely. So at least 4 of them failed the bounce test. So you can take it as P. If they are talking about at least 4 not failing the bounce test, this is probability of, this is Q actually. P will be 1 minus this. That's why you need to read the question carefully. In this question, it's just straightforward. P is 0.1. X follows binomial distribution of 10, 0.1 in AI. They want you to find at least 4, which is 1 minus less than or equal to 4 or less than or equal to 3. We get the table value. And then for I, more than 1, fewer than 5. So we don't need 5. So we take till 4 minus, we don't need 1, so minus x is less than or equal to 1. So I'm going to get these table values for n is equal to 10, probability is 0.1. So here n is 10, the probability 0.1 is in the second column, as you can see here. Okay, as you can see here, 0.1 is in the second column, n is 10. We need the value of x is 3, which is 9872. This is 1 minus 0.9872. So your answer is 0.0128. That's all. Here, 4 and 1. Take the values for 4 and 1. For 4, it's 9984. 0.9984 minus. For 1, it's 7361. 0.7361. So 3, 2, 9 minus 3 is 6, 9 minus 7 is 2. That's the answer. Part B now, hypothesis testing. The managing director makes changes to the production process and claims that these changes will reduce the probability of tennis balls failing the bounce test. So it was P is 0.1 before, now he believes that the changes reduce the fail. Okay. After changes were made, a random sample of 50 balls were tested and found 2 failed the bounce test. That's the observed value. Take 5% significant level whether or not this result supports the managing director's claim. You need to write H0 is P 0.1. H1, he believes that the probability is reduced. X follows binomial distribution of, okay, assume that H0 is true. So X follows binomial distribution of 50, 0.1. Since it's a lower tail test, we need to find P of X is less than or equal to the observed value. X is less than or equal to 2 for n is equal to 50, P is 0.1. So n is 50, P is 0.1, X is less than or equal to 2 is 1117. The probability is 0.1117, which is bigger than the significant level, right? If it's bigger than the significant level, do not reject H0. So we accept H0, we reject this, so that there is no evidence to support the manager's claim. So you need to write there is insufficient evidence don't just write do not reject or accept H. Do not reject H0 or accept H0, you will lose more. You need to write related to this context. So there is insufficient evidence to suggest that the changes reduce the probability of its tennis balls being failed, of its tennis balls failing the bounce test. You need to write that actually. That's all. You need to write the conclusion. Let's look at part C. In a second random sample of n tennis balls, it was found that none of them failed the bounce test. Okay. So they have taken a second sample. In the first sample, they have taken 50 of them. 2 failed, right? And after the hypothesis testing, we rejected the manager's claim, right? Okay, now they have taken another sample and none of them failed the bounce test. As a result of this sample, the managing director's claim is supported at 1% significant level. Okay, we got H0 is this, H1 is this. This is manager's claim. When do we accept this? When the calculated probability is less than the significant level, or the observed value lies in the critical region. These are all the 2 conditions where we reject H0, right? So here it's already says we rejected H0, we supported the manager's claim, right? So definitely the probability we calculated, that's x follows binomial distribution of n, 0.1. We don't know n. In fact, we are going to find n. So when we calculated x is less than or equal to, none of them failed, 0. This is smaller than the significant level. That's why we rejected H0, right? So x is less than or equal to 0 is same as x is equal to 0. So we can write the formula NC0 p power 0 q power, q is 1 minus p, n minus 0 is less than this. So 0.09, sorry, 0.9 power n is this. Take logarithm both sides, you can put the power in front. Log 0.9 is less than log 0.01. When you divide by log 0.9, log 0.9 is a negative number. So you have to flip the sign. Log 0.9 is a negative number. Okay. So log 0.01 over, you get 43.7 dot dot dot. Therefore, take the next integer, 44 is the answer. So in this sample, that means they have taken 44 balls actually. That's all.